Good afternoon, everyone, and welcome to the third instalment of our restricted access piling webinars. For those of you who weren't present in the previous two, they were restricted access board and restricted access driven. But today we'll be focusing on specialist restricted access piling. And for those who were present, you'll be familiar with the two presenters today. Those are myself, Oliver Dawson, and perhaps one of the most experienced members of the mini pilot team of Roger Bullivant, Dave Johnson. So what we'll be talking about today, these are the topics. So we'll do a little bit about our business, Odex piles, drill bar, jack down piles, slab under ream, and then quite important that we've got a question and answer session at the end. I'll also say that there's a survey to fill in. If you could please, your feedback's very important and it helps us to improve future webinars. And also this is being recorded, so if you do miss anything or you want to come back to it and review it, you can do through our website. So a little bit about us then before we begin. We're part of the Solitons Fresnay group. So as you can see there, a group of companies. We are under the Solitons battery arm. Within that arm, there's ourselves, Soil Engineering, which are a site investigation contractor. Battery Solitons, who deal with the larger diameter piles, rotary board, diaphragm walls, and being part of a big group such as this, it allows us many things: financial stability. We can call on the expertise of the various people throughout these groups. And if one member of the group isn't best suited to your project, then we can get in touch with another member of the group who will surely be able to assist. Roger Bullivant ourselves, so we operate out of 8 individual area offices throughout the country, and this gives us an advantage in that we've got local engineers with local knowledge, and that we've always got people available in your area. So if you need somebody to come out and have a look at your project and talk you through some things, which is the best options for your sites, then we've got people available to do that. And just some of the other techniques that we do, there is some webinars as well for these individual techniques. So main fleet piling, driven precast, CFA, CHD piles, onto ground improvement, so vibro stone columns and dynamic compaction. Precast foundation system to complement the piles that we put in the ground. We also have a precast system that can go on top to give you a full foundation solution. And onto restricted access piling, which is what we'll be discussing today and have been discussing in the previous 2 webinars, which is our smaller fleet of rigs for working in restricted headroom, restricted access. And so without further ado, I'll pass you on to my colleague Dave Johnson.
Thank you, Oliver. Right, we had 2 first webinars talking about displacement piles and board piles. What we're going to cover today is the bits in between, the bits that were missing. So first of all, I'd like to cover Odex piling. Now, Odex to the piling world is a bit like Hoover is to the vacuum cleaner world. It's one type of drilling system, of which there are many on the market. Where you've got ground which is obstructed, or you've got hard ground that you need to penetrate and you can't get through with conventional augers or even drive through it, then we have to turn to rotary percussive drilling techniques. which is using a hammer and tungsten bits, similar to what they use in the site investigation industry, where you talk about open rotary boreholes, but we turn it slightly differently and we use it for piling. Now, the problem you have with open rotary drilling is trying to form a pile is that the ground will generally fall in behind you. So the challenge is to take down a casing or something which will provide a stable bore while you're advancing the drill down into the ground. So this is where ODS, or overburden drilling systems, come into play. Now, as I've said, there are many on the market. But looking at this presentation, they basically split into two types. On the left, we've got what we call the reamer type systems, Odex, Superjaws, Tubex, a lot out there, but they involve a physical way to drill a slightly larger hole than the casing that sits behind. So you can see there that there is a ring which sits behind the pilot bit, and as the drill goes into the ground, the ring spins out and it drills the slightly larger hole. On the right-hand side is a ring bit system, where the system engages within the drill shoe, and the drill shoe itself turns with the drilling system. So the whole thing turns, and there are tungsten bits on the ring bit. Now, this is a far better system when you're drilling through much harder ground, because you've got a full face drill there, which is penetrating the ground. So there are advantages and disadvantages to both. Probably the biggest disadvantage to a ring bit system is that it's very expensive. You lose every time you drill a hole, you lose that tungsten tipped ring bit. So that's quite expensive. But if we just advance forward, this is the basic installation of the Odex type pile, where we're taking a casing down behind the drilling system. So we drill into the ground and we rotate clockwise. We've got a hammer sitting behind the drilling system, and that will be giving the percussion to drill away at the ground, and the air flush clears the drill tip and brings the material back to the surface. So we're drilling forwards, and once we've got into the rock and we've taken the casing down as far as we need to go, we then rotate the drill system backwards, which tucks in the over-reaming ring, and we can extract the whole lot back to the surface. We then go back down with a standard button bit and a DTH hammer, and we form a rock socket into the ground and fill that with concrete and with reinforcement. If the ground's wet, then we use standard tremming techniques, but essentially you're forming a pile socketed into the rock and cased through the overburden. This is just to show the type of machines that we use. Essentially, all you need to provide is rotation and a machine that has the capacity to lift the drill string back out again. So the deeper you go, the heavier the drill string, the bigger the machine you need. This is a 6-inch Odex system with a mini rig, which will sit with a remote power pack. It's only got a 1 meter stroke, so it's quite slow to penetrate. It shows you that you don't actually need large machines if you're going to try and employ this technique in restricted access. Looking at the other type of system, LMX is typical. Where I said before, the actual drilling system engages with the ring bit. So the ring bit and drilling system go down through the overburden into the rock, disengage, and come back out again. And you can see on that center photograph or the illustration, the ring bit which is left behind down the hole. They're several £100, so you could have a good specific reason to use this type of system. And then once that's out, you go back down again, socket into the rock, and fill the hole with concrete and reinforcement. One of the benefits of the LMX system is the way that it controls the airflow. With the reaming system, the air tends to go into the ground itself, whereas with the ring bit system or the LMX, it balances the airflow sufficiently that it cuts and it clears the face of the drill, but it's got a way of exiting from the face of the drill and back up inside the casing. This is very important if you're drilling next to sensitive structures or anything where putting air into the ground might cause a problem. If you've got water-bearing sands, for example, you could cause liquefaction or disturbance to the ground. And mine workings is another example where you don't really want to be pumping a great deal of air into the ground if you're going to disturb ground gases and things like that. So there are subtle differences between the two, and we choose the right drilling system for the right ground. This is a job up in Scotland using the LMX system. You can see we're outside, we're using one of our bigger drills. This is a sonic drill with a 4-meter stroke, and you can take 4-meter casings down at a time, so it's much quicker. And you can see there on the center the yellow drilling system, which is engaged in the black drill ring bit. And you can see the grooves engaged into the center of the drill system that allows the air to exhaust and go back up inside the tube. So on the right there, you can see the air, and well, you can envisage how the air and the chippings, all the drill cuttings, are coming up through the center of the tube, and we're up against some fairly sensitive structures there. So that was the right choice of drill system for the right ground conditions. Here's a little video.
Proven by seasoned drillers, the new LMX system has revolutionized their way of working. Conventional down-the-hole drilling systems push compressed air straight into the ground. In clay, sand, or other sensitive ground conditions, this makes it hard to predict exactly where the air will go and how it will affect the surroundings. But with the new LMX system controlling the airflow, the difference is obvious.
So it controls the airflow across the face of the drill bit.
The redirection of the airflow is what makes the LMX system unique. Once the air reaches the bit face, it's blown against the extended ring bit walls and is redirected to flow across the face. In this way, the air pressure is decreased just enough to allow an efficient flushing of the bit face without escaping to the surrounding ground.
Right, I think we're back again. Right, thank you. That was Odex piles, or drill and case piles. Moving on, we've got a similar type of pile in that it will penetrate through hard ground and it involves percussive drilling. But this is what we call drill bar piles, where we don't need a casing to hold the side of the ground open. We're using a grout flush, and we're using that as a support fluid to keep the sides of the hole open. Now, these have been around for a while, and they're called various different things. We call them drill bar piles, but they're often called self-drilled micro piles. It's the technique used for soil nails and rock bolts, or even anchor piles. Where you've got to be a little bit careful is they have got good tension capacity, but you have to look carefully at the code if you're going to start using them as British Standard or Eurocode anchors because of the double corrosion protection. So there are ways around it, but you've got to look at your specification for anchors before actually using them for that pure purpose. Essentially what you've got is you've got a long drill bit, your hammer, percussive hammer sits on the piling rig up above, and the drill string becomes the reinforcement of the pile. So you've got a continuously threaded bar with couplers, and it's a hollow bar. So what we do is we pump grout down through the center as we're hammering on the top, and that will flush the cuttings and the arisings back to the surface. You can mix grout with water and have a weaker grout, and in the right ground conditions, if you've got rock, you can introduce air. But it's essentially it's going to be grout or some sort of support fluid just to keep the hole open. The drill bit as well is a one-use drill bit. So you'll be careful in your selection of your drill bit because they're designed to go down the hole and just be left there. So these are the different components that the system's made up of. You can see the threaded bar there. It's got a hole down through the center, down which we pump the grout, and the grout emerges through the ports in the drill and the drill bit at the end. The circle in the center, they're the most basic type of drill bit you've got. They are what we call clay cutting bits. They've got no tungsten on them. They're just cast fittings, and they go through soil. Up on the top left, you can see a more robust drill bit. He's got a little bit of tungsten on the tips, so he'll go through some boulders and some gravels, and he'll make his way down through there. But if you're looking for penetrating into rock, you may have to use button bits, which are the ones in the bottom left, something with some more robust tungsten on there. Conventional couplers, as you would get with, say, a tie bar or a divvy-dag bar, to join everything together. We have spacers to keep the bar central, and then there's no end of components to finish the things off once you finish, nuts and plates and ways of incorporating them back into the structure on the top. This is the installation process. Basically, you start at the top and you're drilling your drill bit into the ground using the hollow bar, and you add more hollow bar as you go down through the ground, and all the time the grout is coming back to the surface, which can be recirculated. And once you get to your design depth, which is the third illustration, we tend to then up the grout strength to the final specified the final specification, and that comes back up to the surface, and we literally stop once we're happy that we flushed everything out, and the pile is the grouted core and the bar down through the center. See, one of the advantages of this type of pile is the oversized and irregular grout body that's formed. Typically on, say, a 75mm drill bit, the hole that you form is of the order of 200mm, which gives you plenty of tension capacity and a lot of shaft friction. You can see there on the second photograph how we've chipped away just to expose the bar down the center, and you can just see one of the couplers. So it does have, whereas through the CFA pile you're trying to avoid such situations, here we know that we've got full grout body cover, and we take advantage of this irregular sized surface. Plant-wise, you can install these things from excavator mounted masts, or you can buy bespoke track bodies on which you mount your hammer. Down on the top left there is a little Marini machine which will operate off scaffold, and he's got a remote power pack. Quite flexible in that the mast will come off that, and we can then mount it onto excavators. So it needs remote power packs and compressors and things to go with it, but it does give you the flexibility to get into places and start drilling and holding things back. Little quick case study. This is a project we looked at a couple of years ago. It's an old railway cutting which now forms a hospital car park at the base, and it was someone's driveway at the top. The top of the retaining wall collapsed, and we were asked to come up with a cost-effective solution to pin everything back. This is what we came up with, was we built a timber crib wall on top of the old Stowell Railway retaining wall, used the drill bar anchors or tension piles to go into the rock, and that's prevented the sliding reaction on the base of the crib wall. Incorporated that into the foundation, and then we built the crib wall off the top. We also used, in the bottom right, you can see us installing Syntec anchors just to reinstate the integrity of the stonework on the lower retaining wall. And there's the finished job. So I was quite pleased with that. It's came out really well. But it just gives you an example of the sort of things that we can put together. And in this sort of specialist restricted world, it's more a case of presenting the challenges, and we tailor our systems to come up with solutions to people's problems. Our third technique that we look at today is what we call jackdown piles. It's a relatively simple technique in that it involves pushing something into the ground, be it precast concrete or typically steel tubes, using a pair of hydraulic rams. It's completely vibration free and silent, so we can use it inside buildings. We get very high capacities with these rams, up to 1,000 kilonewtons, and it's self-testing. We tend to use load cells. So as we're jacking the tubes into the ground, we'll introduce a load cell and we'll hold the load, a bit like a static load test, but not necessarily for quite so long. But we're proving the pile capacity as we're installing them. One thing that you've got to provide is a reaction. You can do that with either using water tanks, pallets of blocks, or typically on underpinning situations, we use the structure itself. This is an example of an old historical structure where the front gable wall was had moved away from the body of the building, and it needed underpinning but tying back in such a way that we couldn't use typical percussive piles, and we didn't want to undermine the foundations. So we went for a jack pile solution, which involved putting in a new slab and gave integrity to the building before we then installed the supports. We went in and we needled into the walls, taking out the brickwork pockets, installing temporary supports, and then fixing reinforcement into the needle pockets. We fixed the slab and a downstand edge beam. The edge beam on the jack pile system has to be reinforced upside down and the right way up, because as you're jacking, you're imposing forces and bending to the opposite way to what you have when you have your permanent condition. Now you'll see there are 3 steel tubes. They're tapered steel tubes taped over at the top. They are to facilitate the jack piles after we've cast the slab itself. Excuse me. Steel tubes come up through the reinforcement. We've got some couplers welded onto there, and they sit proud with the top of the concrete, so they sit above the reinforcement there. That's the concrete going in for the slab. And then we come along and bolt our jack rig onto the couplers, which you saw. And we use the hydraulic rams to push the steel tubes down through the slab. And the wall to the right is acting as kentlage to hold the whole system in place. Once we get down to depth and we've tested the load capacity, we fill the tubes full of concrete, and those tapered steel tubes then anchor into the slab. There's a little case study here, final one for jack piling. This is in Hereford, if anybody knows it. It's an Edwardian facade on a building which actually encompasses a Tudor timber framed building within it. It's very odd. And it's built over the old city moat. So there's the plaque on the outside. Now down in the basement, Barclays had a problem in that the vaulted old cellar was starting to collapse. They've been repairing it over the years and it was continuing to creep. The ground was going down and the arch was springing. So there's quite a lot of dilapidation. We had access problems in that the only way down there was downstairs behind the tellers. We couldn't have any vibration. Ventilation was an issue. It's quite sticky down there. So we had to come up with a bit of an innovative solution. And as you can see, the headroom was quite a challenge. What we came up with was a jack pile solution where we cored a hole from one of the upstairs lobbies down through into the basement. And that's how we got down the reinforcement and all the concrete for the slab. And then we built ourselves a bespoke electric jack down rig, which was silent, no fumes, and that could pump 120 kilonewtons maximum load, using the building itself as the Kentledge. The lowest part of that sprung arch was at 1200 mil, so we could only use very small strokes, sort of 6 inches at a time, to push the tubes in. So we were using shims and pieces of steel roll sections just to facilitate the jacking. But that went really well and allowed us to support that what potentially was quite a dangerous building. Right, our final section today. This is basically a case study or something that we've recently done in a brewery where we've got a warehouse where the client wanted to increase the loading on the floor by introducing a computerized racking system. Racking system is 40 meters tall and it's full of beer, so it's very heavy. So the existing pile slab couldn't cater for the increased loads. The client didn't want to take the floor slab out and start again. He wanted a more cost-effective solution of upgrading and increasing the capacity of the floor slab. Now, when you put piles in through a floor slab, conventionally, before you put the floor slab on, an efficient way is to put a pile cap on the top to increase your shear perimeter, or to put a flared head. Now, what they wanted us to do, or the design for the new piled slab, was a 1300 millimeter diameter enlarged pile head, but we had to do that through a 400 millimeter cored hole. So we had to find a way of actually under-reaming under that slab. What we did was we spoke to our in-house plant design department, who came up with some tooling, and the technique we used was that we drilled a pilot hole down through the center of the cored hole, and then we introduced this tool which was fit within 25 millimeters of the cored hole. On the left there you can see when it was collapsed, and it basically acted like an upside down umbrella. So as we rotated, we lifted the arms and that cut away and formed the underream. The tool under development, you can see the cutting arms and the teeth going on there. It was quite important to set the top arm so that it cleaned off the underside of the floor slab to ensure that we got correct load transfer. And that's the finished tool, ready to go to site. Here's a little video just to show you an animation which we produced for the client. There we go. So you can see we had a pilot hole down which we dropped the collapsed under-reaming tool. The piece on the top there, which you can see, is a special bearing we manufactured so that we could attach it to a piling rig. The big steel ring we clamped into the bottom of the rig. We attached the center spindle onto the head of the piling rig so we could provide rotation, and we could lift the tool to make it cut as we rotated. So we were using a conventional piling rig and this tooling. And as it rotated and cut, the cuttings dropped down into the pre-bored hole. So we were catching all the cuttings and forming the under-reamed shape. We then took the cutting tool back out, lined the under-ream before we went down with a conventional CFA pile, and pulled the casing out to form the under-ream with concrete. So it all worked very well, 1,300 piles, and the client was well impressed. Right, thank you very much. That's essentially the end of my presentation. We've got a couple more presentations coming up in the next few months, principally around the residential sector. They're all advertised on our website. If you'd like to look at any of the previous webinars, they've all been recorded and are on our website, where you can download them and look at those at your leisure. If you'd like to ask any questions, or we'll move to the question and answer session, Oliver's going to take over and run us through those.
Yeah, well, it looks as though you've done a fantastic job, Dave, because there's not a great many questions to actually answer. So if you do have any questions, please feel free to add them. We do have one here. This one came in when you were talking about drill bar piles, but I think we could shoehorn it into to all the piling techniques. It's a question I'm sure you often get asked. So let me see if I can put this on the screen. What type of capacities can you typically expect to achieve?
With the drill bar piles, it depends on the size of the pile and what you're trying to achieve. Like with everything we say in the piling world, it depends on the ground conditions. Some of these, particularly, they're very popular on the continent. You can take well over 1,000 kilonewtons on some of the bigger drill bar piles. And in tension, they'll easily take 200-300 kilonewtons. So you get some decent loads. But sometimes you're not even looking for big loads. If you're using them as soil nails, or you're looking them for tie-back anchors, you don't need particularly high loads, which means you don't have to go to depth. But it all depends what you're trying to do. Obviously, one thing that you do struggle with drill bar piles is lateral capacity. You've only got the center bar, so they don't take a lot of shear, but they are good in tension.
And what about Odex piles then, Dave? What sort of diameters are we usually dealing with, and what sort of load capacity would you expect to achieve?
Typical range of an Odex pile is sort of 150 to say 250 millimeters. They're the sort of typical sizes. With drilling, because you're talking about using quite expensive kit, as you start to get bigger and bigger, it gets disproportionately expensive. So you can drill large holes, but you then start looking at cluster drills and different specialist techniques. We have got drills up to 600 millimeter diameter, which again you get 2,000-3,000 kilonewtons if you're in the right ground conditions, if you're in the right rock. So you can go down and drill quite large holes. The other things we didn't speak about on the talk today was the type of casing you use. You can use the Odex piles or over drilling systems to take down thick wall casings, and that will enhance the capacity of your piles, both vertically and in shear.
And what sort of shear loads would you expect to be able to take? Because obviously we're talking quite small diameters when we're Odexing. So what sort of shear capacity do you think you'd be able to achieve?
You would easily get 50 kilonewtons, possibly up to 100 kilonewtons. On the larger diameters, we've used them for slope stability problems. I used it last year on a rock face where we had a fault line, so we had to design the shear capacity of the pile to resist the sliding of the rock face. So so there are quite specialist applications to these pile types.
Well, that's all the questions, but I'll ask some other ones, Dave, of people that typically.
Some of the questions have accidentally gone into the chat function, so I'll just put them on now, and then if we can either respond here or on email later, either will be fine. They should now be.
Okay, yes, they're coming in now. So here's one, Dave. I'll put it on the screen. What was the percentage cost saving of developing the slab underream system compared to the cost of replacing the floor slab?
I can't answer that one. I wasn't party to the calculations. But there was not only the cost saving in terms of direct cost of the concrete and construction costs. It was a technique that we employed which was relatively undisruptive to the brewery's production facilities. So we could work our way across this floor slab while they were still loading it out. So they were still using the room, whereas if you were to rip the whole thing out, then they would have lost that facility. And during lockdown, storing beer was quite a considerable consideration. So there would have been other add-on costs or disruption which would have come into play.
Okay, thanks, Dave. Can you confirm if Odex piling is the most suitable technique for piles on a sloping high wall surrounding a former open cast mine?
Yes, brilliant. Particularly the ring bit system. The ring bit system drills a nice straight hole, and it will cut into a high wall. So we've done this many times. What you tend to find with a board pile or with a driven pile, it will skip off a high wall. Or if anybody doesn't know what a high wall is, it's essentially the size of a quarry. And the Odex piles or the drill and case piles will cut into it and core into it, and it'll also deal with any quarry waste. That's one of the problems with drilling quarries or piling in quarries, is that often they throw a load of rubbish in the bottom, large boulders, and traditional piles will go down and think they've hit the bedrock at the bottom of the quarry, whereas they're on some loose material which may cause long-term settlement. So yes, piling round quarries and high walls is ideally suited.
Okay, if you'd like to speak to someone about that, Claire, then please get in touch, and we'll perhaps come out and see it and discuss the project in more depth. I can't see any more questions unless there is some hiding anywhere. There's none on my screen.
No, that's everything now, Oliver.
That's everything. All right, thank you very much. There is a survey to complete, if you'd be so kind. It's on your screen now. Thank you very much for joining us today. We hope you enjoyed the presentation, and please get in touch if there's any requirements.